Moving into ammonia. Nitrogen has 5. 3 hydrogens, so we have a total of 8. How you orient your hydrogens around here, it's not going to make any difference. So I've used 2, 4, 6, 8. All right, so how about this? This is kind of weird. And the formula doesn't give you a lot of insight into the structure, but let's count our electrons first. 2 nitrogens each with 5, 4 hydrogens each with 1. So we've got 14 electrons to deal with. All right, so these nitrogens, notice there's not an odd number here, so one doesn't naturally just tend to go in the middle. So let's put the nitrogens in the middle because, well, hydrogen can't go in the middle. All right, so let's connect those. And again, as long as you draw me a valid Lewis structure, it's going to be okay. But because I like symmetry, I'm just going to draw an H on each of these nitrogens. That's my personal preference. If you want to put 3 on one nitrogen and 1 on another, you can. It will be okay. So here, 2, 4, 6, 8, 10. Now, each of these nitrogens only has 6. So let's try this, see how that works. 2, 4, 6, 8, 10, 12, 14. There we go. So you can draw me a valid Lewis structure, meaning hydrogen's not in the middle. You have a skeletal structure, you use the correct number of electrons, and everybody has the number that they want. Hydrogen has 2, and everybody else has 8. H2O2, this is also kind of tricky. Let's count our electrons first. 2 hydrogens, 2 oxygens. Looks like we also have 14 electrons. So hydrogen cannot go in the middle, so I'm going to connect my oxygens, and because I like symmetry, I'm going to connect them like this. Again, if you want to put them another way, you can. Just make sure it's a valid Lewis structure. We haven't talked about formal charge or anything at this point to discuss why one is better than another one. Okay, so I've got 14. I've used 2, 4, 6, 8, 10, 12, 14. Good deal. CF4. Hey, this one's pretty easy. 4 for carbon. So I've got 32 electrons to deal with. Orient them around. I do not care about your angles. If you had somebody before that wanted you to draw them with appropriate bond angles, great. I do not at this point. Lewis structure is a Lewis structure. All right, you do have to put in all the dots. We have to account for all the electrons. If you want to draw your bonds as dots, you can do that as well. As Cl2, 6 for sulfur, 7 for each chlorine, so we have 20. All right. Again, you can put your chlorines up and down, you can put them next to each other. How you do it, that's going to be all right. 10, 12, 14, 16, 18. Hold on. 2, 4, 6, 8, 10, 12, 14, 16. There we go. 18 and 20. Okay, C2H6. Okay, it's kind of a similar situation as what we had with this N2H4. First, count up your valence electrons. You have to do that. Use your periodic table. After a while, you'll probably not need the periodic table. So it looks like we got 14 electrons. 8 and 6, yeah. So let's connect these carbons to each other. And because I like symmetry, divide those up. Well, that's good because carbon can't have any more than 8. So that helps. So 2, 4, 6, 8, 10, 12, 14. We use them all.